Okay, I'm gonna turn the lights off now. I turned them all on before I found the one to turn, the ones I wanted to turn
That should
on.
be a qualifier question.
It's it's the lowest probability event that I just did, but it happened anyway, so. Okay, welcome to our weather discussion. As we start off every week now, you've been watching this movie for a while. I just want to tell you some things that I found interesting in it, and I don't know where they're going to occur. One thing is, you'll notice continuous confluence right around an axis like this, the flow out of the subtropics that comes across northern Mexico, and then occasionally extratropical trough-like disturbances coming across like that. You'll see maybe a couple of examples of that. That has resulted in some really disastrous flooding for central Mississippi, as you probably heard in the news. And so there's been one round of heavy precipitation after another. Some of these disturbances have matured into massive cyclones in the North Atlantic. Here's another one of those cloud masses that kind of got a leaf structure to it. This is going to take on a substantial cyclonic structure as well as it gets out over the North Atlantic. But here's the beginning of that week, and not really raining everywhere in Mississippi in the early time of the week, but it's going to become more evident. Then later in the period, I want to also note, you'll see it up here south of Hudson Bay. There's a cyclone that comes across central Canada with the counterclockwise circulation in the northern part of that region of Hudson Bay. And then there's an obvious anticyclonic circulation that you can see at the Watervik, but I think you can see it in the cloud. And that'll kind of migrate across Ontario into Quebec over a long period of time. Really pronounced evident feature. Maybe it won't show up the infrared as well, but this infrared. But don't change it. But the thing I noticed all winter long is that there's been more examples of obvious anticyclonic cloud motions in and around ridges this winter than I've noticed before. And I can say that with some confidence because I give a weather discussion every day in my 100 class. So I've been doing that for a long time. And I just haven't noticed as many of them as I have this year. So they're kind of obvious. I think this is the cyclone that's coming up. Let's see. You can already begin to see some of the anticyclonic swirl. Yeah, here's the cyclone. And you don't see it quite as well in this as you do in the infrared, but I mean the Watervik channel. But that anticyclonic portion goes roaring across southern Canada, and it's very, very obvious as a closed circulation in the Watervik channel. So that's good. Okay, so let's leave this. Thanks, Pete. We'll start with a approximate satellite move for the grayscale over the continental United States. So here's our satellite movie in the visible across the continental United States. Here's the cloud mass that we saw just at the end of the prior loop, heading up toward maritime Canada. Cold air coming off the continent, and we'll see that in the surface observations in just a minute. This is, you don't often see this stratocumulus over the Gulf of Mexico. You very often see it over the North Atlantic, Massachusetts Bay, Gulf of Maine, and you're seeing it there as well off the coast of New Jersey. This is less common, but it does happen, of course, when cold air makes it all the way down to the Gulf Coast and gets, moving out over the warm Gulf of Mexico. In fact, this is the month for the record cold air outbreaks in the southern United States. It's February. It's usually earlier in February, and the record one was 1895, where I think there was snow in Jacksonville, there was snow flurries in Miami, and temperatures were in the single digits in southern Alabama in some of those mornings in February of 1895. So it must have been something like this kind of structure that would have brought those kinds of conditions. Now, pay attention to the fact that all of this is snow, so it's not moving as we go through several hours of this animation. Most of that's true also in the Intermountain West. I would venture a guess that the only clouds one actually sees on this map over the landmass, or over Florida, as the front makes its way offshore. A little bit of stratocumulus over southern states, a little bit of a tropical intrusion over, southeast Arizona, so Tucson area, and then southern New Mexico. Other than that, since the entire continent, the continental 48, are dominated by high pressure, which accounts for our beautiful clear skies, you see almost nothing else going on across the continent, which is really remarkable.
I'm not certain of this, and now if we have a blow up of the northern Georgia area, but that cloud stream that's starting off in North Georgia may be results of lake effect off of Lake Lanier. That was the Weather Forecast Office.
And Zach Handlos wrote me last night about that. He said, we might get some snow flurries off of Lake Lanier in northeast Georgia because it's cold air. And I was going to save looking at the surface observations for a minute, but the temperature never gets below 35 in Atlanta, but that's cold enough to snow, and the dew point's like 32 or something to see a flurry. So this is Lake Lanier right here. Is that right?
That may be just a regular stratocumulus.
Lake Lanier is a little bit east of that.
Okay, so I can't see it then on the map. So it must be.
pretty small. It kind of blends in with all the trees around there.
Okay, so that might not be the best candidate for actually making lake effect precipitation of any kind, then if it's too small and shaded by effectively antennas, the trees. So, but interesting that all the stratocumulus, when you take a close-up look, it's all this sort of this roll cumulus, which is characteristic of the nature of these cold air outbreaks. So it's really kind of interesting. So probably not snowing in Atlanta.
Right.
And I think Washington DC hasn't had any snow all winter. Is that right? Or they haven't had an inch of snow in months?
Nothing, no.
Jason was talking about that in his blog the other day. So, and here's another thing. We'll keep an eye on this on the Delta region. You'll see. I don't know how long it'll be now. Maybe about 5 weeks, early April, late March. You see it bloom, and suddenly it's not gray anymore on the visible. It turns white. You really see. Even when the land is just tilled, it changes its color in this scheme. So that's kind of interesting.
Turns green on the other one.
Yeah, I know. Yeah, but that's more obvious. So I like to see it be subtle.
But the other thing that's also gonna be nice is, probably right after spring break, or even just before, on the Friday before, you might actually see those cumuliform clouds beginning to develop across southeast United States, just as the ground is getting warmer, and you're getting a little bit of.
Oh, yeah, that's right.
convection.
Beautiful population. Almost looks like the penguin pictures we saw a couple of weeks ago. They're perfectly spaced. They all have their own little circulation. They can't encroach upon each other. Okay, let's go to the radar across the continent of the U.S. Yeah, and there's really this testifies to how little sensible weather is really going on here in terms of precipitation. A little bit of lake effect off of Lake Ontario, and then this is some of the precipitation associated with the broader cloud mass that's off the coast. And it's cloudy over Florida, but it's not precipitating. So those are sort of those probably shallow but fair weather, not shallow roll clouds associated with the cold air outbreak. We don't see anything precipitating over the Gulf. We wouldn't see it much beyond about that distance, but nonetheless, nothing there. And then a little bit of precipitation, as I mentioned, in southeast Arizona and central New Mexico. I'm not sure what these features are migrating along the coast of California,
Right.
other than an alien invasion or something.
Right, some of that might be actual precipitation far out, to the west of the Channel Islands out there. But
Oh,
that's,
yeah.
that's gonna be, that may be our weather, or part of our weather, or associated with a disturbance that'll be affecting our weather early next week.
Tuesday or Wednesday, yeah.
It looks like you're running that loop in reverse, because you never see features that are concave or arc features.
I know it's weird. It's really weird, isn't
In that
it?
direction, yeah, I mean, that's really odd.
Well, I say, I don't know if it's weather related or not, but it's coherent.
It's associated with the cyclone that's off the coast if you look on the fullness imagery visible in the
Oh, yeah, I know that, I've seen that there's something spinning around off the coast, but why do you have a convex band moving poleward away from that thing is really curious. That's weird. So yeah, here's the cyclone that Kelton's talking about. And it's even further offshore, actually.
There's a band, yeah.
It looks like a portion of the game.
Yeah, it's very weird. That's the thing, right? Yeah. Oh, man. There it is.
I think one thing to look at is, those are the visible in the Gulf of Mexico. I'll tell you what's unusual about it. You can see all the linear bands that are coming, really benign bands, and these stratocumulus are because of cold air moving off the continent. And yet, the subtropical jet is way north of it. So the upper levels are all tropical air. The lower levels just have this low-level Arctic air that's moved off the coast. So it's a, I don't know if that's a completely odd situation, but it's over much of the southern half of the U.S. where we have subtropical air at high levels and then relatively Arctic air at low levels.
Yeah. Well, we'll see some of that when we go to the upper level charts and see what the winds are doing at various levels. So that's interesting. Keep
Look at those clouds coming off of Florida too.
Yeah, these are racing across that high level and then underneath that.
But on the tip of Florida, see I think those might be squall lines that are.
Oh, right here.
There was a precipitation band associated with that.
Yeah.
There is a close up to Florida for full res.
How come? So special about Florida.
Yeah, those are.
It's warm.
Was one.
Yeah, it was warm. In fact,
You see the curl in the flow too off of.
yeah, right off here. Yeah, that's really interesting. Yeah. What kind of temperature infection is going on here? If all you had was this information, you can tell, right? If you got southwesterlies aloft, most likely, northeasterlies at this level, right? So that's, well, you can't tell. You can't be sure it's veering or backing. I think it's backing. But it's backing with height, I think, and so you get cold protection on that. Sometimes when it's almost 180 degrees difference, it's hard to tell which way it's going. Okay, so let's go to the West Coast satellite image. And then we'll come back to the continental surface odds, which are interesting in a number of places. So here's the West Coast image. So here's the cyclone, the center of the circulation Kelton's talking about, and then the cloud shield is off to its east. And then we were seeing that funny thing going up along the coast. It loses some of it. You don't see it so obviously, except that right here, that's got a smile shape to it at the early part of it. So that is off. And then here's a plume coming forward over northern Mexico from about what longitude is that? 130 degrees east or west, I mean, 150. And then broadly speaking, the North Pacific is divided between relative warm air, and here's the jet feature that we'll probably see in the upper level charts, and then much colder air forward, and I can tell that by looking at the popcorn cumulus that's all the way across the Gulf of Alaska and the southern Bering Sea. So that's much colder air. I'll guess something like minus 30-ish at 500 millibars. We'll see whether that's true. And down here, it might be about minus 25, minus 30 also, in and around that circulation. But a fairly benign eastern half of the Pacific, a fairly benign continental U.S., so it's one of those weird days where there really isn't that much well-organized and fierce, teeth-bearing sort of weather across the country. So that's nice.
Yeah, it's kind of odd. I mean, just that plume that's originating from the subtropics, just on the southeastern part of the map.
This here,
Yeah, that the sort of banded structure
Oh, yeah.
is really just bizarre.
There must be tons of gravity waves at the top of this thing. Greg, is that what you think when you see this?
Yeah, I'm just looking at this, the inertial stability is very low.
Okay, so these are
It's a tropical plume in the form, so it basically, you have very low I squared inertial frequency, and so a lot of the geostrophic balance is breaking up.
yeah. So you get all this waviness on the mesoscale. So that is interesting. They don't always look like that. You're right.
Yeah.
Sometimes they have this weird pancake structure, almost like a spring, and then other times they're much more placid.
That's basically spookification, as I call it.
Yeah, I thought of that word when I looked at this morning. Yeah. Okay, let's take a look at
Did you have a question earlier? I know your hand was up for.
It was for the south Gulf Coast imagery. There's some weird cloud forms over Texas.
Okay, and you don't have to put your hand up. I think you know that. You're a veteran. You can just say it. And that's true for anybody, of course, not just the veterans.
For this, the Gulf of Mexico region?
Yeah, the visible.
So what?
Sure,
Over
just-
the Texas-Mexico border.
You see like a shadow.
Oh, yeah, that's interesting.
Oh, yeah.
That's a shadow, I guess, from higher cloud. That's probably what that is.
Is
I don't
it?
know. Let's see. Let's think about the timing.
But there's
Or is
another
it clear like that?
I mean, more to the south.
See that?
I don't know. I don't think it's a
whole
shadow.
boundary.
Yeah.
I wonder if
It's also an arc going the wrong way.
Yeah.
I wonder if this would
It's a
be.
weird day. Very weird day. Yeah, that looks like clearing.
Yeah.
Very weird. I wonder what's going on there.
Huh.
I don't know the topography well enough to think that there might be something associated with something about the topography, but I don't think that's it.
Yeah, I don't know it well, but I wonder if it's clouds that were banked up against the mountains in Mexico. Now they're just moving modeling northward,
Yeah.
so they're left with a.
It's really interesting.
I wonder if the surface odds will be enlightening all over.
Good note.
There's not too many down there.
Okay, let's go to the surface odds next, and let's start, well, you know what, let's go to the T-1 hour, just because it has analyses on it, you can kind of place yourself in the context of the larger scale circulation. I like that. Yeah, so here we know we're in the middle of the big anticyclone that's centered right about on the Oklahoma-Arkansas border. So we slide to the east peak, so we can look at the east coast first, and then further north, and then we'll come down the coast. So here's the anticyclone center, and so it's chilly, light snow at Provincetown, so there's snow off the Massachusetts Bay, or light effect off the Massachusetts Bay. Cold and dry, look at these temperatures, 27 over 0 in northern Connecticut, north of Hartford. It's 27 over 14 at Chatham, or at Provincetown, and Boston's off, I can't see all the numbers, but everywhere, dew points are low. Portland, 23 over -4. So this is cold, dry, polar air. And when it comes out over the Massachusetts Bay, which is probably 55 degrees or so, maybe 50, there's plenty of room for evaporation that turns into some snow along Cape Cod. So that's interesting. We're 25 over 10, so a reasonable late winter morning, not really too cold, and we're going to stand to do a lot better as the weekend progresses. Can we slide to the south and take a look at what's going on in the southern states? Next. So in Florida, look at this. If you're at Jacksonville and it's 45 over 35, you are thinking about the end times, right? You don't like it to be 45 degrees in Jacksonville. That's why you moved to Jacksonville. So you'd never see that again.
Yeah.
But there it is. And it's late February. And it's 72 in Miami, 67 in Fort Lauderdale, 63 further north along the coast. So the cold air hasn't made as much southward progress as the winds have. You can see it's northerly all the way across. Tampa's what, 56? Yeah, so that's really cold. The Panhandle's in the couple of stations are a little warmer, but the Panhandle and Jacksonville really cold for that part of the country. 42 over 28 in Atlanta. So, maybe there was a chance. I think there was a good statement for the Weather Service to make. I'm not sure about the lake source because it sounds like it probably isn't really big enough to do that. But this area isn't cold enough to dry it.
Someone that works in that office said that it was basically an upper level frontage in the system, seemed like terrain influence.
Oh, so it wasn't just the lake.
Yeah.
Okay. So there's some other reason. Because we did see isolated pockets of clouds that weren't just the Rayleigh-Barnard convective poles. So they had that right. I don't know if that actually precipitated. And then cold in Alabama. These are temperatures in the high. In Birmingham, it's 38, 35 further to the north. It's in the 30s in Mississippi. It's been raining there all week, so they've had excessive flooding, and then they have temperatures in the 40s near Jackson today. This is almost noontime for them, so they're really not enjoying this, I'm sure. And here's a nose of high pressure that goes down along the mountain, the lower elevation, the mountains of Central America and Mexico are right here, and so the cold air just funnels down along that. It's a classic picture. In fact, it's on Hess's textbook. The front cover has that kind of a picture.
Not really anything super instructive down here about that clearing. So.
No, sorry, we don't notice this, yeah. But it's 51 over 40 at Brownsville with a roaring 15-knot wind out of the northwest. That's not nice. Nobody likes that down there.
Oh.
So, imagine 2-3 weeks from now, it's spring break, and people are going to South Padre Island. You don't want this happening then, because then
That's the problem with South Padre Island. It's always so windy.
Yeah, I bet it is windy down there all the time. So. Let's go further west now, if we could, Pete. And so we noticed some radar echo in southeastern Arizona and parts of New Mexico, so there's some light rain in western central New Mexico. And that's about it for this in the observations. And then we had some interesting weather along the south coast of California, but nothing showing up as a precipitating event in these odds anyway. But temperatures around 60 to 68 near the Bight and south of it, so pretty decent day, not too bad. And then there's this little pressure trough, which induces offshore flow and probably makes the valley a little warmer as the day wears on and it starts out. And the last thing I wanted to point out was how warm it is just to our west. So we're in the midst of a transition since Wednesday afternoon till about this morning. We've been in either northerly flow, northwesterly flow, or light to no flow. Now the anticyclones move to our south and east, so we're into the southwesterly flow. And that's coincident with weak flow over the high terrain to the west. It's not really strong. It's weak, but it's strong enough to make the temperatures in the so-called banana belt of South Dakota into the mid and high 40s. It's 48 at this station here and 41 at Rapid City. So it's, this is all subsidence induced to really produce a warm bubble, 46 down here in southeastern Wyoming. That air we don't care, and the atmosphere doesn't care that the air's been warmed by compression. As soon as it gets warmed and put in lower elevation, it's sent to the northeast, and that's going to warm us up. So we'll see that increasingly in the 850 millibar forecast over the weekend. It'll be warm advection supported by continued subsidence to the west. And that's going to give us a nice weekend, it looks like.
What's that huge cycle way up in Canada?
I guess we have to slide further north, and it's not going to, we're at 982 at this position of it, so this is a big storm over Hudson Bay. This is the one that I think had that anticyclone in the water vapor that's kind of racing across at upper levels, Ontario.
Is that unusual to have such a big cyclone?
I don't know, I don't think so.
So I know at 850 a lot of times, at upper levels, you see it spinning around a bit.
Yeah.
Over Hudson Bay.
So let's take a look now at the upper level chop. It's not at 500 millibars, Pete, with the super peak. So here's the 500 millibar analysis. Late February, this looks more like early February, late January. It's very baroclinic, very energetic flow over North America and adjacent to waters. This is really high speed geostrophic winds, easily over 50 to 70 knots at 500 millibars. Here's a really nice upper baroclinic zone that's in a region of strong horizontal shear, and so that's probably going to be an upper vortex. I think in the water vapor imagery that we were watching before we began, it was clear that was a dark spot in the water vapor imagery, so that's a low tropopause, high PV region for sure, and probably getting more so as time goes on. And then here's the cutoff that Kelton drew our attention to early on. It's cold aloft. This is, let me see if I get the temperatures right. This is minus 20, so that's minus 25. Yeah, it's minus 25 there. And over the Gulf of Alaska, this is the minus 30, minus 35. So it's about minus 35 south of the Aleutians, everywhere else minus 30. So about right based on what it looked like in the convection. Not really a good environment for the development of that wave that went off the coast. This is way too straight a flow. It's very strong, and if you're on the anticyclonic side, shear side of it, that's not really going to turn into much of a cyclone, I don't think. Here's the feature aloft associated with the storm over central Hudson Bay. It's not very baroclinic, but it's got a nice curvature maximum, and it's got a downstream ridge. So there's a really good reason for ascent to be going on over Hudson Bay in a strong flow like that. Let's go to 300 millibars. Greg had mentioned that we had jet structures aloft on top of the cold air that clearly was funneling southward in the lower troposphere. So here it is, and it's clear, not so clear at just this level, but I've seen the other ones, that this is a subtropical jet, and it's at a fairly high latitude, as Greg pointed out. 208 knots just south of Newfoundland in this feature. I think this is now probably combined polar and subtropical jet by the time you get that far north. That can be determined. And then here's a polar jet that's actually dividing the Gulf of Alaska from the cold air to the north, populated by the convection, and the much more uniformly warm air to the south, so as one might expect. And here's the wave, and it's got two jet streaks associated with it that's driving some of the development over Hudson Bay. So let's go a little higher just to separate polar from subtropical. 300 is always ambiguous. Let's try 200 instead and see what we see. Yeah, you don't see much of that polar structure at all over central Canada. You still see this one, so that's a pretty intense jet. But this is clearly a subtropical jet. And 161 knots at 200 millibars, it was 208 at 300. So the core, let's see 250, see what the core is. The core is stretching from 300 to about 250 millibars. So that's clearly a subtropical jet and a very intense one. So I'd love to see a cross section through that. We could do it with tropical, but I won't waste the time to do it. Then let's go down. One more thing I want to say is go down to 850 millibars peak so we can see what's happening in the lee of the high terrain. So number one, as Greg pointed out, we have a fairly intense cyclone and a developing environment for it over Hudson Bay. So there's already a preference for a warm sector in this location, south of that cyclone. If you couple that with the fact that the flow at upper levels is at least west to east, it's not strongly west to east, as I mentioned. We don't have a jet feature at this latitude coming across the high terrain. But it's west to east enough to reinforce the warming that goes on in the immediate lee of the high terrain. So the temperatures in this warm sector, especially down over in east of the high terrain of the Northern Rockies, are quite warm. 7 to 6 degrees over 32-degree dew point depression at Rapid City. It's +3 there. It's +6 at Aberdeen. And so it's really quite warm. The analysis is rather ugly, but it's a warm bubble right about in this location. And that is upstream of where we are. So long as the subsidence continues to reinforce this, and then the westerly winds from that location toward us that vected our way, we're going to keep on warming up at 850. And that's a nice picture. Here's a nice example of the difficulty that this storm will have in developing. The only way that it's going to be able to develop is to have locally intense frontogenetic activity, much like this November storm. That gets picked up by an potent wave. This one probably won't. It's going to just propagate along the very coast and not probably get that much more intense. So there's a lot in the weather today, even though it kind of strikes you as rather boring, clear over the whole continent. There's a lot to talk about, as there always is. So I think that's all I
I
have.
had a request from a couple of online viewers. Apparently there's a tropical cyclone affecting Samoa, American Samoa.
They want to hear some more about it?
Yeah, let's hear some more about that. American Samoa, home of ball players who don't have birth certificates. So you can say you're 22 when you're 35. I almost tried it once when I was young.
Guessing this is what we're talking about. Southwest of Hawaii.
I don't know. I think it's further west than that. I don't know. Is it, what's the, any coordinates, any
The
further?
tropical
specification.
page of some.
Who was this mystery person? So, yeah, that's Vicky. That's it.
That was from the so east of Australia.
It actually isn't at least when I was trying to do it, it wasn't showing up. The, oh,
There you go.
170 west, 73.
Where is it? It's in the clear
Just on
spot.
Southern Hemisphere.
yeah, if you click animate, I can see.
Any gift.
I'm very confused.
Also, if you look at the tropical page, there's like 3 things overlapping. I don't know if there's multiple.
Yeah, I really haven't looked at this, so it's not,
Okay, we'll just zoom in or anything.
in this area, so that's a separate one.
Yeah, there are.
Oh, I see. There's 3 different things. Yeah, okay. That's not just a weird thing.
So that, oh yeah.
It's still the same.
I'd be hard pressed to say where anything is and all that.
Seems
So,
like there's some rotation west of the other.
Yeah, so
That might be where
wherever,
the investment.
yeah, wherever
It
the,
is 13
it's
degrees
going south.
That's very south.
The large cluster near the island is, I'm assuming what that Vicky is.
Or maybe very
And
sheer,
south.
because it looks like none of the plot points they have are really near the deepest convection.
Yeah, you can click on shear up there, satellite derived products, shear, to see.
right, yeah.
So it's getting into a more sheared area. You can also look at taking off shear and putting on convergence divergence. It's surface convergence and upper level divergence to see. So I think Vicky is a hot spot. in the northwest. That would be propagating itself and dying out this year.
All right.
All right.
So,
It
forecast.
should have been west.
It's a little salt. Okay, we're gonna look at the forecast for this upcoming weekend and early next week. It is gonna be relatively quiet. Just one comment on last week's discussion, we were talking about the warm-up that occurred, and it did warm up a little bit over the weekend, but it didn't warm up as much, and it appeared that when we're looking at the orogram for temperature, that we would have sort of temperatures being flat or increasing over much of the weekend, and we actually, I think Saturday night into Sunday morning was actually a pretty cold night.
Yeah, it wasn't quite
single
consistent.
digits.
Yeah, you're right.
That may be something that's just an artifact of the model. We'll look at, also take some time to bring up the weather program and look at the Moss numbers for Madison over the course of the weekend. But generally, a warming trend depicted by this model. We'll check out the actual, we don't look at these numbers specifically because there's a lot of sort of misrepresentation of how the boundary layer structure is. This is a pretty coarse model run, but the general trend appears to be warming up and getting a little bit more moist in terms of increasing dew points, and very little in the way of chances of way of precipitation for us.
Interesting, looking at here, the difference in the rate of heating and cooling. You know, it heats up so quick during the day and then it just slowly cools down. It heats up really quick.
That may be something to do with how the surface is represented or the boundary layer processing model, but it's not something.
Snow cover.
Look at that, snow cover could play a role. And if it does not play a snow cover, this is an old version of MM5 way back on. Okay, let's look at the time height section, which also is a pretty quiet time height section, not much going on. See the lowering of the dynamical tropopause. You can see sort of increases in the height of these isotropes as the tropopause is lowering, so there's certainly a relationship there with the upper troposphere cooling. But really, in the lower troposphere, there's not a lot that's happening. You can see the winds varying with height in the lower troposphere, and you can also see at these levels the isotropes lowering, so warm advection occurring over this layer. A pretty stable layer over us. We're not going to mix deeply over the next couple of days, but also the snow cover, you're not going to anticipate that. But a pretty much southwest flow over us through Sunday, and then the flow will be a bit more westerly Sunday afternoon into early evening. So brisk westerly to southwesterly, or southwesterly flow becoming more westerly over the weekend. Right now, it looks like dry conditions for this, and in terms of precipitation, and obviously as we cool off at night, we'll see the relative humidities going up with not much change in the water vapor content. So quiet weekend for us.
One of the things that didn't happen last weekend that I thought might was fog on Sunday.
Right.
And there was none. And I'm wondering about this weekend. Are we missing that as a potential situation? If the air is dry and warm, and it comes over the snow, you'd think it would do a little bit more sublimation.
Right.
But I don't know.
But it'll also be tough if it's depending how dry it is. I guess you're not going to approach
Saturation, yeah. But you're also not going to mix it out. So you can't. There's no escape valve. So if the air does get close to saturation, how's it going to mix out? It's probably going to fog. But I don't know if it will. And we have a maximum in fog in the state, especially along Lake Michigan shore, and beginning now to about the beginning of April. That's the time when it's really foggy. And I wonder if this isn't one of the situations that leads to some of those fog days. I don't know.
We'll take a look at that.
Yeah.
But yeah. So this again, just based on this, looks pretty quiet over us. Let's now go back and look at. We'll start off with maybe a slightly different look that we don't normally look at. Let's look at the 305 to 315 isentropic layer. Look at the vorticity, but we'll actually start at 6 hours. We'll first click through it, get a sense of things. So here's that trough that we saw in the geopotential ridge in the PD, if you will, just off the east coast of the United States. This elongated area of higher dyes and potential vorticity associated with a minimum geopotential. You can see the cyclonic curvature associated with it. But this feature just beginning to exit the coast. Again, the structure of this, just looking at it, as John was suggesting, is not really conducive for any sort of cyclogenetic development. A small bit of PD in this wave to our northwest. They'll be vectored toward us, but again, it's the higher dyes of well into Canada. And the most conspicuous feature off the west coast is in fact that cutoff that we saw, some of the showers ahead of it, near the Bight of California this morning. I'm going to watch the progression of that. And this is really a cutoff of the traditional and not the traditional, but the real meaning of cutoff on this level. It's isolated from the background potential vorticity gradient, and it's going to be just the direction which it's going to move is governed by all the things surrounding it. And also it's the lack of its symmetry is also going to contribute to some of its propagation that really relies on the environment to move it around, as opposed to wave-like structures like this that can propagate like maybe more traditional Rossby waves. Let's go ahead 12 hours, please, to midnight tonight. You can see that cutoff slowly progressing toward the east. Any shape with it over us, that little trough has gone by and we're back into this rigid PV, but the upper trough has gone by. We have lower potential vorticity advection, or low PV advection, or worse, negative PV advection at this point as this feature moves by. But again, nothing upstream of us to really ruin our weekend at this point. We can go ahead another 12 hours to noon tomorrow. We'll loop this in a second. That trough feature continues to propagate by, but you can again nicely see the slow eastward progression of this upper trough as it moves to the southwest. It's under these upper troughs. If we were to do a cross section through it, maybe we'd go to tropical tidbits and do something like that before we're finished. But you would see a nice, I would imagine, a nice cold dome beneath it, lower stability and more shower activity versus parts of Southern California. This might be one of the weather producers. This is the type of structure, particularly the more intense ones, at other times of the year, that produce their thunderstorms or their hail and things of that sort, because it's so unstable beneath it. With lower stability underneath these high positive potential vorticity anomalies that can lead to some convective precipitation.
Yeah, and March is the coldest month of the year at 850 in Los Angeles. The average 850 temperature is never colder than the month of March. So this looks like the beginning of that progression.
So there's also a period then of frequent cutoffs then?
Yeah, I think so. Yeah.
Okay, so that's kind of interesting to see that. And then again, most of the continent of the United States, just based on this map, is sort of weather free. The main zone, the Rossby Wave Highway, if you will, is well to the north. So
Looks like a June map, not a February map. Or maybe late May or something.
Let's go ahead another 12 hours, please, to 42 hours of forecast. Good night tomorrow night. Trough is dominated on shore. Again, when we do the loop, you'll see it's pretty much maintaining its intensity. Whatever precip's occurring is probably not deep enough to really erode the potential vorticity. There's like minimum that's affecting over us tomorrow evening. But again, we're really, away from, the jet's well more north, at least the polar jet is well more north on this particular map. We'll finally go to 60 hours in the forecast around the south. And see this upper trough has arrived beginning to arrive into the southern plains. And then, I guess the issues with this, we have to look at the surface map. Is there any significant variant ahead of this? Could this be a potential for some interesting, severe convective weather as it moves to the central plains? Is it moist enough? Is there sufficient bearing as this upper trough moves to the southern plains? Okay.
It's kind of interesting, I think I know where you're going. This is like a drunken sailor coming off the west coast, and it might have a role to play in Tuesday and Wednesday.
Right.
So how predictable is it?
How predictable is it? Is this something that's going to follow this particular track? We have a couple of these other PV features that are being injected around. But let's do a loop now, please, Pete. And just follow that. Again, since we're on this isentropic surface, to the extent that if the flow were adiabatic and frictionless, and frictionless might be okay with, but adiabatic, a little bit concerning the vorticity should be conserved. So the maximum we see at the initial time should stay the maximum for the entire time. But you do see this weakening somewhat as it moves eastward. Not so much affected by the mountains, perhaps by some of the precipitation that's going on maybe beneath it. But initially, it's maintained its integrity pretty well as it moves into the plains. So if we were to switch this and go to look at the 500 millibar map, you'll see a very similar evolution. We can actually just do the loop just for time, concern of time. Here comes an upper trough. It really maintains its curvature, but you'll also notice on this map, it looks like it's kind of embedded within the overall flow. So this PV anomaly, which is cut off on the isotropic surfaces, is a little bit more wave-like, but still, it's a very tight, coherent vortex. It's not a wave in the potential vorticity field. It's a wave in the geopotential height. So you can see the evidence of that.
Yeah, and then the other ingredients coming in over the Pacific Northwest in that northwesterly flow. Yeah. So how do they get their act together, or if they do at all?
Right. So that'll be the interesting aspect of this to watch, is that interaction. And we'll next go to the loop for the surface map. We'll look at the precipitation structure associated with this. But again, for us over the weekend, it's going to be pretty quiet. You can see the strong warm advection that's set up to our south as this ridge slowly migrates to the east. The tropical ridge migrates to the east. But significant precipitation across the southwest, and then begins to sort of blossom over Arizona and New Mexico as that upper trough approaches. You can see the thickness is really low, so that's going to be evidence of those colder temperatures in the lower and middle troposphere. But for us, we're kind of high and dry here. No precip. There's a little bit appears to be light precipitation, but I don't just kind of discount that in terms of actual precipitation. But really strong warm advection, thickness is increasing to our south. Let's look at the same animation, but look at it from the perspective of we'll go to the pivotal and look at the GFS. And we will go to, let's start at 24 hours in the forecast. We can see the beginnings of the showery precipitation in the Bight of California, and then over parts of, the Phoenix and southern Arizona, some convective precipitation, perhaps light convection over us. Sort of warm thickness advection. Again, this is a really quiet pattern, probably an enjoyable one tomorrow after the cold weather we had earlier this week. This is going to be certainly portend a warming trend. We go ahead 36 hours, and warm advection continuing. In the peaks in the Rocky Mountains out to the west and southwest, we're seeing a little bit of snow in the higher elevations, but largely liquid precipitation for this particular weather system. Let's look at 850 millibars, please, at this time. Temperature and height.
The Brewers are supposed to open against the lowly Texas Rangers tomorrow for spring training, but it looks like they may have some rain to contend with.
So it's going to be, looking at temperatures, we're approaching, 7 or 8 degrees C at 850 millibars just to our west. Nice warm advection. Again, later in the year, when we have dry ground, you can add 12 to that, and I'll tell you what the high temperatures are going to be in degrees Celsius. But we're not there yet. But lots of warmth to our southwest. Let's go ahead. Back to the surface, and we'll go to 48 hours, so Sunday morning. Again, pretty quiet here. Hopefully we're nearing the end of our warm advection as heights or pressures are beginning to fall toward north, flows becoming more westerly. We saw that in the MM5 forecast, westerly, sort of more of a call between the cyclones sort of southwest and the ridges out over here. But westerly winds could lead form advection, but it's not particularly strong, and the precipitation beginning to break out for plains. I guess this configuration, let's go ahead 12 hours to 60 hours in the forecast. Okay. There is some, heavier convection that's occurring over parts of Kansas and Oklahoma at this point. I haven't looked at SPC. I don't know if anyone's looked at that for Sunday.
It's too dry, basically.
Too dry.
There aren't enough mixing ratios, but it's sad because the hodograph is probably one of the better hodographs I've seen in terms of curvature. It's just going to be listed on that.
Right, like southeast winds here, and then at upper levels, it's more out of the west southwest. So that's unfortunate, but it's severe weather. No one's really excited about that anymore. But for us, again, quiet weather. It looks like, again, temperature convection is probably at this point pretty much neutral at this point. Let's go ahead to 84 hours. That's like a decent cyclone, but it doesn't really get advance far enough to the north for us to get much in the way of precipitation. There is a little light rain and snow along southern parts of Wisconsin into northern Illinois as the cyclone moves eastward. But again, not a very exciting pattern for us. But thicknesses have come down to cool off a little bit with an east wind on Tuesday or Monday afternoon to Tuesday. Cooler day, kind of cloudy, gloomy, with maybe a little bit of light precipitation, but better chances to our south. Let's go to 96 hours, please. Tuesday morning. The cyclones advance to our east. The precipitation is lingering, and part of that's due to this upper. You can see ends up at a thermal trough that's out to our west. It's perhaps associated with a very weak upper trough as well. This cyclone's kind of in the wrong place. If we could actually go to the 500 millibar heights and vortices, that would be the dynamics page further down. Oh, that was last year. That's right. I know where it is. It's over northeast Kansas. Cyclone. So the cyclones here, the thickness contours, if you recall, were also going roughly in the same direction. Not much for the cyclone to go on in terms of intensifying. The advection by the thermal wind of the vorticity level is pretty much nil. That's not going to be much contribution to upward vertical motion over that cyclone or even much to its northeast, I would say. It's a pretty weak cyclone. And the one that emerged from the cutoff has now just become this little blip that's over parts just near Pittsburgh. That's really washed out. Okay, back to the surface map. We'll just click to the end of let's go forward in the week. Go to 120 hours, 5 days out. The cyclone steadily just weakens, moves into the Detroit area, and go back to turning colder again. Southeast begins to warm up and gets showery again. And 168 hours just to end the next week. So cold, windy and cold. So back to a cold pattern. And look at the temperatures in this forecast for the 12Z on next Friday. It's back to the single digits again. So we warm up a little bit. What I'd like to do, Pete, is go to the weather program and bring up the MOS from Don Madison. Just take a quick look at that. What Pete's bringing up is guidance that forecasters use, and they're preparing forecasts, whether it's weather service or local forecasters on TV and media. This is statistical representation of forecast, taking the GFS forecast / new avian loss, the GFS, and challenging the forecast with actual observations and figuring out corrections for errors. This is the forecasted temperatures for tomorrow, 43 with a low tonight of 19. And then on Sunday, a high of 45. That's going to be a nice day. Low of 27. Tomorrow looks nice, just a few clouds, generally clear. And it looks like Sunday is a little bit cloudy, broken in terms of the overcast. By the time we get to Monday, it's going to be overcast. Probabilities of precipitation are relatively low, less than 3% or less during that period, and no chances of convection. And the most likely chance of precipitation is generally snow, although if it were precipitating, few chances actually need to be liquid precip here. And you can see the wind direction predominantly out of the southwest, becoming more westerly late on Sunday, and then northwest eventually shifting to east once we get the front goes to our south and the cyclone begins to develop toward north, or toward south.
That's all right.
Not a bad, okay, then we could do new MRF Moss.
Just watch out in the mornings, because after the melt, you get this
Freeze up.
ice you can't see.
Yeah, and then this is the, from the GFS, sort of extended, forecast. This is going out, for the rest of the week. Here's our climate, we should be at 36 over 17. So we start off the week, at least up until Tuesday, above normal. Monday's a little bit cooler, but not much cooler, according to this, the weekend, and then we turn colder on Thursday and Friday.
Snow probabilities in 90%.
Yeah, it was like the type of snow and then precipitation probabilities. You can see midweek, they get up into the 12-hour precipitation, likely it's 60%. The greatest chance of precip will be Tuesday, I guess, at the Wednesday, and things kind of dry off after
Snow.
So, quiet weekend, not much exciting. We'll watch the cutoff coming out of the southwest. Maybe the one last thing to do if we go back to pivotal is just look at the East WF, that's all in right now, and go to the surface map for that. We'll call it the
You gotta go to high res.
high res. Yeah. And go to,
So much information there over the months.
let's go to, just we'll go through the weekend, we'll go up 24 hours. And this unfortunately doesn't have the thickness contours on it, but you can see that broad southwest flow as this ridge stays. But go to the southeast, go to 48 hours, and still dry, westerly wind. And there's that cyclone beginning to develop.
It's better organized than these.
Yeah, and it pretty much moves straight east, if I'm
Yeah.
correct, if I recall in this. Let's go to 1,000. 1,003, beginning with northeast. So this is Tuesday morning, light snow just to our south. And let's go ahead 6 hours, under 2 hours. So it looks like this model is forecasting period of
A little bit more.
steadier light snow, 108 hours. So you can just keep clicking to see that with the light snow over us. And just keep clicking, see how long this event lasts according to this pretty well.
Oh, here comes another, that's,
That's persistent.
yeah, if something redevelops on the western side of this. This is more like the old GFS.
Right.
In that regard.
And so if we look
Yeah,
at
okay,
the total
so-
snow totals for this event, scroll down to the very bottom.
Less than a foot, I'd say.
Yeah, I'd say probably less than a foot by weekend here. So total snow for this event, look at that.
Whoa.
That's not bad. 11 inches in northern Illinois. And if you wanted to compare this with the GFS, over that same time period,
Hey, we got a little bit of a
you
mass
actually
right
get
there.
this even with that light snow that's persistent.
Yeah, so half a foot, maybe. Wow.
But I wouldn't,
And what I think, I'm glad I'm not a professional forecaster. This is a miserable scenario because you're watching this thing, like I said, this drunken sailor come stumbling back over the continental US. You don't know how the upstream features are really going to phase with it. Man, could be worse, could be a lot less impressive.
Right.
We get a lot of our snow this way.
Yeah, I know, that's right.
it's almost accidental. I mean, it's,
Yeah, it's accidental in the sense that it's a mix, it's like a tossed salad and,
everything has to come together.
yeah, it has to all come together.
And the persistence of this, I think, is what gives us this. It's not that it's a big forcing for significant snow.
Right, that's right.
Hour after hour after hour, it's
Yeah.
just little bits accumulated.
It's fairly persistent in the forecast, though.
Right, this is in the forecast, but it's the,
Different forecast times, it's there.
Oh, yeah, the snow is, but not strong. There's never any strong force.
Right. There's never
It's just a long duration event.
no.
Kind of like what we had last week.
Let's look at, just for those that want to stay around, if we were to go back and look at a prior run, just
Yeah.
how has it evolved the forecast? So from last night's run,
Whoa,
it's a little bit lighter, but that's actually
that's amazing, that snow event. That's about the same.
there too. That's about the same.
This is locked in.
Now you just jinxed it. It's getting locked in.
Looks very similar in every single one of them. That's unusual. That one's the first one that really departs it.
We've got like 6
For
or
us.
7 runs that have been
Yeah.
persistent.
Look at that X across the, X marks the spot Des Moines. Or I don't know where it is.
Cedar Rapids.
Yeah, Cedar Rapids. The place to be.
All right.
Mondays that you showed?
Oh, it's green
here.
20, was Monday when you showed the forecast, was 20 inches?
Oh. I forget.
There's something from this
Right.
last week.
Yeah, there were forecasts earlier this week that had close to like 16 to 20 inches for Madison. But wow. Looks like it's going. So quiet weekend, and then early next week, we could get to a period of snow, and the question is how long, the duration of it, and the intensity of it.
That's the one, that's like a week old almost, early this week. Yeah, that would
And if you go to, Continental, go to.
Would have been all-time single-day snow event.
We zoom in. These are old forecasts, and then go to regional. Upper Midwest. Yeah, that's one of the runs.
20.4.
Thank you, Bill.
That would have broken our all-time single-day record.
And the current forecast is from the GFS. Bring that back.
What you were saying about it being frustrating, John, is not only is it like high impact, but also you're right on the gradient.
Yeah, oh, yeah, that's right, that's right. Someplace will get a lot, but it won't be you. 6.7 is okay.
That's
You
good.
live with that.
So light to moderate for a long
If
period
we
of
actually
time.
got that, that'd be the biggest one of the year.
Yeah, no, that's right. I think you're right.
And you even see, I guess, evidence of the convergence along the lake.
Yeah,
shore,
lake
the east
effect.
wind, right?
Look at that, 10.8 at Gracie or something.
All right, well, thanks, John, for the presentation.
Thank you, Michael. Thanks, Pete.
For anything, and, let's see if we have to shovel this.
Snowy, we got it snowing in January and we had a great down the since then. So
Let's not,